So this is a little different than the other papers in that this isn't about Israel, though Mayor and I have talked about doing something like this for the uh, for Israel, and maybe these results will actually cause this to happen. But it is about inequality, and it's about the role of education in affecting the wage distribution, and therefore it is about inequality. And the normal way, the first way we think about the education affecting the wage distribution is in terms of the distribution of educational outcomes in a population and the rate of return to education. And there's other educational features may play a role, but these are less well studied. So this is about some of these other features. It's about institutional features, and in particular, it's about the extent to which there are strong or weak linkages between specific educational outcomes and the occupational distribution. So in some sense, it's about how education affects the wages through occupation, but are not primarily interested in this as an individual phenomenon, but rather as a characteristic of the institutional system. So there's been work going on in sociology and other disciplines for decades on the issue of comparative education studies on how educational systems differ, and Yossi Shavit has been one of the, or maybe the leading, with Walter, the two leading contributors to this literature in the past couple of decades. It goes back to a study that Marie Cellier and Sylvester did back in the early 80s. I think the research was done in the 70s, trying to make sense of what they called the social foundations of industrial power, the Germany and France being the two industrial powerhouses of continental Europe. And the question was, how did they produce the training of the workforce that realized this industrial power? And they argued that they actually did it in very different ways, and they became sort of polar cases, with the French system being called an organization space because it was seen by them as primarily a hierarchical education system, and people get hired based on where they fall in that educational hierarchy, then they get trained, whereas the German system is seen as a horizontal system where people get credentials. Jutta Almendinger, Alan Kirchhoff, Yossi, Walter Buehler have looked at characteristics of education systems, such as the level of standardization, the amount of tracking, the vocational specificity, and these have been treated as sort of aggregate sort of country level characteristics, and then. Our fields of study become important in recent years, and a number of scholars are looking at rates of return to fields of study, and all these things are important. And so we're asking a somewhat related but different question, which sort of follows from the observation that these national level characteristics of education systems may hide substantial heterogeneity within countries in education systems. So countries differ not in one global way, but they can differ in different ways depending upon where you are in the educational system, both in terms of level and in terms of field of study. So there's these two questions that we're asking, which are sitting over here on the screen. Is are the returns to education partly a function of the occupational destination that school leavers with specific credentials wind up in? And national education systems differ in the extent to which they create weak or strong linkages between school leaving credentials and occupations. And do these institutional differences affect the structure of inequality? And we're not going to talk about it today, but it may also, and probably is the case, that they also affect the distribution of educational outcomes. So one of the things that I've been interested in for some years now is the low rate of persistence to degrees by tertiary students in the United States. It's very low relative to most other industrial countries, and so there's probably three explanations for this. And one explanation is that post-secondary education is expensive in the U.S., and a second explanation may be that that there's lots of American students going to post-secondary education that don't have the academic preparation for it. But a third thing might be that the American system in general is defined. I mean, not everywhere, but relative, for example, to Germany, there is a lack of clear pathways between school and work. for a lot of routes, and that could be a reason why people don't finish. In contrast to the German system, where you pretty much need a specific credential for anything skilled, consequences of dropping out are more serious, because if you don't drop out, don't have a credential, you can't get a skilled job. That's not the case in the U.S. So these were all motivations for looking at this. And so, we're looking at here is we're looking at the relational character of educational system. That is, the ways that educational outcomes connect occupational destinations, and the differences both within and between countries as well as over time. So I'm not going to talk about the over time aspects of it here either, but this is, there is sort of a general perspective, I would say, in the social sciences that institutions are hard to change, which is one of the reasons that the characterizations of these educational systems for these major European countries in the US have been pretty much constant over decades. And so one of the things that we're doing in another paper actually is looking at the extent to which the French and the German systems have changed since the 70s, because as it turns out, there's very good data for both France and Germany. And it turns out that systems can change. And in fact, again, this isn't this talk, but the French system is not as different from the German system as people think, and it's moving in a German direction over the last 30, 40 years. Which, again, from an American perspective, is like good news at some level, because it means institutions can change. I'm gonna, well, I said most of this already. And why might this matter for wage outcomes? So, well, here's some conjectures. I'm saying they're conjectures as opposed to like hypotheses, because I'm not testing them here. Okay, but it is plausible that the structure of linkage between specific educational outcomes and occupations, may affect the wage distribution. And there's like two kinds of conjectures, it seems, that are sort of natural. Okay, and one conjecture is a conjecture about productivity. So it may be that in a system where the linkage is tighter, where there is clear pathways, that you get a more homogeneous workforce in specific occupations that they may affect the production function in favorable ways, raising productivity that might raise wages. So that's like one kind of like argument as to why that might matter. And another argument is an institutional argument that if the people that end up getting into specific occupations are more similar educationally, maybe they have greater solidarity, which makes them easier to organize, which being organized is another way to raise wages. So those are, again, I'm not testing them here, but they're conjectures that make it plausible that the structure of linkage could affect the wage distribution. And then, a third way is that, inequality can be decomposed into within and between, for example, occupations. When there's greater linkage, you would generally expect lower within occupation variance in wages, which is sort of another impact on inequality. So what do we mean by linkage strength? So, we're basically applying sort of multi-group segregation measures or an analytic structure to occupations. We're using entropy-based measures. Those of you that, there's the index of dissimilarity. In an American also in an Israeli context, people look at residential segregation, 2 groups, index of dissimilarity. When there's more than 2 groups, you need something else. And so these multi-group measures, for example, an entropy-based measure was one way to do it. We sort of generalize this. So the education categories become the races, if you like. The occupations become the neighborhoods. We're using this measure M. M is the average reduction in either. You can go it both ways, okay? So I can talk about it as average reduction in occupational entropy between its overall value and its value for workers with a specific educational level and field of study, averaged overall educational categories, but it's symmetrical, so you can talk about it in the other direction as well. So that's the global measure, but the nice thing about the measure is it's decomposable in various ways, and one of the ways that it's decomposable is it's decomposable into local linkage measures. And so you can come up with a measure for each educational outcome, or alternatively for each occupation, and it's the extent to which the occupational distribution of workers in an educational category G differs from the over-occupational distribution. And as you can see, it's a function of the ratio of the conditional to the marginal distribution. Or you can talk about it in terms of the difference between the joint distribution and what you would predict under independence. Okay, and overall M is a weighted average of the measure that one gets for each either educational category or occupation. So this is a comparison of three countries, Germany and France, for the reasons I just told you, plus the fact that there's good data on Germany and France. And then the United States, which is a little bit more challenging. We're using the American Community Survey, which has fields of study for college graduates, not for community college graduates. So we actually combine it with the SIP data, which actually has community college and occupational certificates as well. There's the issue of graduate degrees, which is where there's two different strategies for dealing with this. One is imputing them from what we know about the occupational distribution and the proportion in detailed occupations that have graduate degrees. The other is using the SIP data directly. The issue with doing this kind of analysis is one needs lots of data, and the analysis that we're doing is so it's basically a giant table. Contingency table, roughly 90 by 80, and we insist on 100 cases within each category, because the thing is, if you haven't got enough data, you get the appearance of more segregation than there is. There's a sparseness bias. Sparseness bias is really pretty low. We've shown through simulations when you have 100 cases. It's actually not so bad with 50. You get below that, and that's not good. So for the Germany, we're using the microcensus. There's some issues with microcensus as well, because the microcensus doesn't have gross earnings in it as personal income. But so we use the socioeconomic panel to look at the relationship between personal income and gross earnings, which actually correlate 0.95. And so we actually impute gross earnings from personal income using the SIP as our basis for imputation. And I think it's pretty accurate. And then for France, we're using 37 rotation groups over a lot of years in order to get enough data. And I think I said most of this. We've done, so we're using harmonized categories because we want to make direct comparisons across countries. We just published a paper in AJS in the current issue where we compare the results that one gets when making country comparisons about the strength of linkage using native categories as opposed to harmonized categories. You can't directly compare native categories, but one can see whether the difference one gets for any country using harmonized versus native categories sort of changes the overall qualitative story, and it doesn't. Of course, the more categories you use, the more linkage you will see. In other words, the more segregation you will see. For those of you who study segregation, you know this, that there's more segregation, the more fine-grained that you get. So we've done analyses with France and Germany where we have more than 200 educational outcomes because there's so much detail in their fields of study, in the 500 occupation categories. For here, we're using ISCO 3 digits, and we're using ISCED, okay, which gives us roughly 80 categories. So let me just so I'm going to give you some feel for what this is, and then I'm going to use it to see what it says about wages. Okay, so this picture here is that, so these are the ISCED fields of study, it's the 2-digit fields of study, and these are measures of local linkage, and the different colors are different levels of education. So 3s are secondary, 4A is a German thing that is sort of on the border, 5B is community college level, 5A is four-year college, and 6 goes to like master's or PhD. And the United States is over there. Now, the United States is different from Germany and France in that there is no field of study differentiation at secondary school. So that's not a data issue. That's the nature of our system. So when we're making comparisons across the countries, with the United States, we're only comparing at the tertiary level. I mean, if you're coming up with the overall linkage structure for the country as a whole, secondary school matters, and it's just very low linkage because people have just secondary school. We've used this the SIP data to differentiate between academic and vocational, which you can see in SIP, that doesn't make a great deal of difference. You can put GED in there, you're getting some differentiation, but not much. But the thing to notice just here is that the countries are, I mean, there's a lot of variation in linkage strength. You won't be able to see it from the level of detail over here, but the countries don't have a dominant, there's not a dominance relationship between the countries, okay? That before doing this, one would have said, oh, Germany dominates France, and the United States is somewhere. It turns out Germany doesn't dominate France. It turns out there's many fields of study and levels for which France has tighter linkage than Germany does. And, you know, if we, well, I'll get to what the overall is, but we need a heuristic, because the question is like, what do those measures mean? I mean, they're entropy measures, okay? So I'm going to give you a heuristic which does, which puts some substance on this. The heuristic that I'm giving you depends upon the specific classification system we're using, which is the 3-digit ISCO and the ISCED. So, you know, with these harmonized categories, you know, it is roughly true that the proportion of workers with a given educational outcome in the 3 most common occupations is roughly 1/5 of the linkage score plus 0.2. Okay, that turns out you get a pretty good fit with that, which means that if the local linkage score is 0.4, it means that roughly 0.2 plus 0.2 times 0.4, or 28% of the workers with that education outcome end up being in one of the three most common occupational destinations for that education category. If the local linkage score is 2, it goes up to 60%, okay? And these numbers are also useful because overall linkage is the weighted average of all of these. So I'll just sort of jump to this picture here, which is just showing overall linkage for all 3 countries. And the United States is sitting at around 0.4, and Germany is sitting at 1, okay? So what that's telling you is that sort of on average, pick any random educational category in Germany. And I didn't tell you what it was, just to make a guess, you would guess that 40% of the Germans in that education category are one of the 3 most common occupations for it. Whereas for the US, you would guess that only 28% are. Okay, and France is in between. So you see actually there's more linkage structure than in France. Germany overall has tighter linkage than France, but part of that is compositional, because as it turns out that German workers are more likely to get education in those categories that link more tightly to the occupational structure. That's just a fact. So here's an illustration. Okay, this is German data. So this is health 586. So this is like 4-year college health. Got a local linkage score of 3.42. This is in Germany. 86% of the people who have that in the workforce are health professionals, which is, you know, a very tight linkage. This is math and statistics at the college level. It's 2.07, which is still, you know, pretty tight, not as tight as that. 41% are in math and statistics, and 60% are computer and associate professionals. This is health at the secondary school level, which Germany has. You see linkage is going down. This is, again, a general characteristic. Linkage tends to be higher at the tertiary level than at the secondary level. Though there's lots of exceptions when you look at the details. But that is a general rule. It's true, and now we see 27% of the people with this are personal care workers in Germany. 25% are nursing and midwifery. Okay, so you see that these scores, they mean something, and they can be translated into something that's substantive. This is just, you know, there's, you know, the professions have very tight linkage. Tertiary tends to be higher. There's a lot of variation. Okay, and that's what sort of makes it interesting. So, you know, let's, you know, get to the issue. What can they tell us about wages? So, fields of study, you know, these are just sort of the contribution to R square of levels of education and fields of study. These are sort of like the numbers that I'm forgetting who, I mean, maybe, Marcus, maybe you were the one who gave us R squares before. So these are on the same, okay, and the dark blue is the fields of study contribution. So, you know, it matters, okay? So this is what I'm going to do. I'm going to do 2 kinds of analyses here. One is a within-country analysis separately by gender, where we're going to regress the log of wages on age, education level, and the local linkage score okay, for these categories, which is sort of descriptive because it's basically attributing all the differences between fields of study to linkage, which isn't true. I mean, but it's nonetheless, it's descriptively interesting. And then we're going to do a between country analysis. We're basically going to stack the countries into a fixed effects model at the level of education categories. So now all the identification is coming from the extent to which wages are different in one country for the other for the same educational outcome, okay, as a function of, as you'll see, as a function of the strength of linkage, and as you will also see, whether the individual is in one of the linking occupations or not. So that's going to be the game that we're playing here, okay? And how am I doing on time? 10 minutes, okay. So is linkage associated with earnings? Well, I mean, I'm gonna give you some words too to, you know, sort of help with this. In France and Germany, linkage strength in this across fields, sort of within country across fields, is actually negatively related to gross monthly earnings at the secondary level. An increase of 0.25 in local linkage, which is roughly the average difference in local linkage strength between France and Germany. And it's about a standard deviation increase in France across fields at the secondary level. So that's associated with somewhat lower earnings, okay, across categories. Whereas at the upper tertiary level, it's associated with higher earnings, okay? But this is in a model that doesn't differentiate whether a worker is or is not in a linking occupation, and that matters. So then I'm going to put in the local this is the linking, the linkage, local linkage measure up there. This is whether you're in one of the linking occupations, one of the three most common occupations, and this is the interaction between the two. And you see that this interaction matters. You know, being educated in a strongly linking secondary level education field produces a negative outcome only if the worker himself is not in a closely linked occupation. So at the mean linkage for ISCED 3B in France, which is about 0.8, a worker in a closely linked occupation enjoys an earnings premium of 7.3%, and it actually gets bigger if the linkage strength for that educational outcome is higher. So it goes up to 9.3% if you go one standard deviation above the mean. In Germany, the advantage or penalty, if you like, of being in the linking versus non-linking occupation for a specific educational outcome is bigger than it is in France. You can say it's 15%, and it gets bigger still if you're in a category that links more tightly to the labor market. And the same story is the case at the tertiary level, that now the mean linkage score is higher. I said that before, that linkage is generally stronger at the tertiary level. There's a 15% advantage of being in the linking occupation. It grows to 17% if you're at one standard deviation above. 10 goes to 12, and 9 goes to 11 for the three countries. Okay, so all of this was about comparing, you know, but looking at different educational outcomes, classifying them by their linkage strength. Now I'm going to stack the data, okay? And so we're going to now do fixed effects. So now the results that we're seeing are results for the same education category across the countries, and we're seeing whether you tend to see a wage premium. Oh, so when I say wages here, we're looking at full-time workers, okay? Because I guess it's the microcensus doesn't make clear how many hours a part-time worker is working. So you can't do good stuff with part-time work. So we're looking at full-time monthly gross wages. And so this right here is the result for a set of analyses, and maybe you, so this is, if you see colors, blue is not in the linked occupation, red's in the linked occupation. This is the United States and France and Germany are over here, so this is tertiary. That's young men, i.e. younger than 45, older than 45, young women, younger than 45, women older than 45. This is France and Germany secondary school. Again, young men, young women, old women, and this is France and Germany only tertiary. Okay, young men, young women, and old women. And in general, as you see, and this axis is the local linkage. There's a local linkage increase on a scale that matches the actual spread that you see in these distributions. This goes to 0.5 and this goes to 1 because there's much more spread in the tertiary than there is in the secondary. So but these are meaningful differences. And as you can see in general, there are wage advantages that come from being in a category that is linking more tightly. There's a couple of places, and I don't know if you can see the colors or not, where these are reversed from what you might expect, which is that being in the linking occupation is better. And they're on the secondary for the older. And so the question of what's going on there. So, you know, I think much of what's going on there is that some of these people have like moved into like supervisory positions and they're being classified as managers. And managers make a lot of money, but they're not a linking occupation because there aren't enough of them to make it one of the 3 most common ones. I say that because I included managers as a covariate, and then these all become sort of positive and significant. So I think that's what's going on there. And I'm probably about running out of time. I guess this right here is showing you the size of these effects. They're not huge, but they're certainly meaningful results. So then, and these are the results at the tertiary level. Okay, so just picking one of them between France and Germany, a 0.25 increase in linkage applies a 2% increase in earnings for young men and women if they're not in a linking occupation, and it's about 4 and 7 for the males and females respectively if they are in a linking occupation. So I mean, there's a pattern in these, these results are, I think, are meaningful. So it seems that it's not just what skills you have, it's the way that educational category links to the occupational structure that's playing a role. And then I guess the final thing I'll say is that, and there also is this effect of reducing dispersion. So again, this is all a work in progress, but this is sort of a simple demonstration of that. So we ran this regression on log wages, okay? Those aren't the regression coefficients, which is we ran this regression on log wages, and then we took the residuals from that equation, we squared them, and then we ran a regression of those residuals on these variables in order to see like what's predicting dispersion. Well, like the US predicts dispersion, okay? That shouldn't surprise people, okay? But local seg actually predicts lower dispersion. Those are actually, highly significant. That the higher is the local segregation. In other words, the higher is the linkage, the less dispersion is there in wages in that category. So what do those numbers mean? Well, they mean this. Okay, so at the secondary level, the mean residual squared was 0.17. So again, a 0.25 increase, which is, and I'm just about finished, so that's good. Okay. So I think the interquartile range for secondary is like 0.3, and for tertiary is about 0.75. Okay. So a 0.25 increase in local linkage strength is reducing the expected squared residual by 6% at the mean. A 0.25 increase in local linkage at the tertiary level, which is now much smaller, that's only a third of the interquartile range, is reducing the dispersion by 4% at the mean. So it's working the way that we predict. So these are our conclusions that occupations shape the wage distribution indifferently in these countries, and that the strength of linkage matters. Workers generally earn more with a school-leaving credential if they're in a linking occupation, with the gain being stronger when that educational outcome links more strongly to the occupational structure in that country. And within education, inequality is lower when local linkage is stronger. Okay, so within country variation in the strength of linkage, thereby is affecting wage inequality. And then there are some extensions. So these conclusions, this is only applied to the full-time workforce. And obviously overall inequality is a function of the distribution across full-time and part-time, and also unemployed and not employed. And we haven't yet looked, though we're about to do that, at looking at whether clear pathways has an impact on the probability of working full-time and the probability of being unemployed, and those are topics for next time. And I'm finished.
Endsman.
So I enjoyed reading the paper, although some people who are mad at me now for not reading other things at the same time, including here in the audience. So I apologize for those people. I think the distinction of school-to-work transitions according to the strengths of the linkage brings us back to the question of general versus specific human capital, where general human capital means that it's useful in all occupations, while specific human capital is more directed towards specific occupations. So this is a question that has been dealt before in the literature. I think the paper does a very good job in, first of all, developing the index, and it's a useful index, and especially its the composition is useful, and also it does a very good job in interpreting the results. So let me just offer a few remarks here. So the comparison between countries is something, I personally try to stay away from this because we always leave out so many differences across countries that we cannot control for. But still, it offers some insights. For example, when France and Germany are compared, then it seems to be that there are no structural differences in the linkage structure, but all the differences are due to compositional differences of fields of study and occupations. But then the question comes to mind is what drives these distributional differences between France and Germany, and perhaps they could be endogenous in the sense that some fields of study the distributions can drive occupational distributions and vice versa. So this is something that is perhaps worth exploring in further research. And for the US, again, there are, as you mentioned, there are differences in the education system of the US and European countries, and this shows up in the results. I will not say much about the effect of linkage on wages, because I think that's at least in the paper, in the version that I read, is somewhat a more minor part of the paper. But the paper also offers many avenues for further research, and I'll try to offer a few more, perhaps. For example, when you combine secondary education fields and higher education fields, you're actually adding apples and oranges in the sense that if I understood correctly, you ignore the secondary school fields for people who went to higher education. Is that correct? So you take the highest level of education, and for that you choose the field of study. Would that be correct? Yeah. So I think
you're not seeing what they majored in.
Right. You don't see that at all. Okay.
You just
okay.
If they majored in something in college, get a college degree.
All right. So
you don't see what they may have.
Okay. So
like in Germany, if they have an Ausbildung, you don't see that if they go to university.
Okay. So I think if there is a possibility to observe what they did in high school, even after they went to college, I think that information could have value. And I think that could strengthen the results in certain ways. And I think also selectivity into higher education needs to be taken into account, and that could be a function of secondary school specializations. And I think we should look at educational choices as sequential. People choose their fields of study in high school, and then based on that choice, they choose their higher education field of study, and based on that they choose their occupations. So this is a sequential process that I think if we treat it this way, we gain more insight into this process. Now, again, if I understood correctly, you take the entire labor force or the entire age distribution of workers And so that actually mixes people in their first occupation and maybe in the subsequent occupations. So if it is possible to distinguish that, that could add something to.
We do that in the HAS paper, but
Yeah.
here we're just using the
Okay. And if you can use that also to map the trends in the linkage strength over time and across cohorts, that could also be very interesting. Let me offer some insights for Israel, because this conference is about Israel. So, as Yossi Zeira mentioned earlier, their school-to-work transition in Israel is quite different. People go to the military for 2, 3, 4 years, sometimes even more. Some people even postpone the military service by 1 year because they volunteer to do some social volunteering jobs. Then they take some time before they go to college. So in one sense, perhaps the importance of high school specialization becomes less important. On the other hand, the military service, for those of you who haven't experienced this, I strongly encourage you. It can offer quite a lot of human capital and social capital that can be very useful in the labor market. So perhaps, and that again, that makes perhaps the secondary school choices a bit less important. On the other hand, when you go to engineering school, for example, and you haven't taken the highest level of math in high school, you're essentially out. So secondary school choices are still relevant. Now, the fact that people go to college at an older age means that they are perhaps more oriented towards the labor market. They are more focused. They make more educated choices about fields of study. You know, I don't see that in my family, but in general that may be true. So perhaps this linkage between high school fields and occupations is weaker in Israel, but on the other hand, perhaps the linkage between college majors and occupations may be stronger. And another thing is that most students in Israel, I think, I'm not sure about statistics, but I think most students work, and sometimes in jobs that will actually take them into the labor market. So that student positions, companies and public institutions, they go to universities and they pick students who specialize in certain fields. They take them for working part-time, and then they continue that after they graduate, and that again perhaps creates a stronger linkage. Let me just show you some data. These are really descriptive statistics from a study that I put out about 2 years ago with the Taub Center, and these are we focused on math, high school math, and high school math goes from in units. The highest level is 5 units, and you can see the high correlation between the level of high school math and, first of all, whether you go to college or not. And if you go to college, I mean, look, for example, at engineering and exact science and computer science. I mean, high school math is extremely important for that choice. So perhaps I'm referring to Sigal's earlier study about the choice of academic field, which is highly determined by high school specialization. And if you go to occupations, and also there is a strong correlation, perhaps not as strong as before, but strong correlation between level of high school math and choice of occupation, despite the lag in time that occurs between these choices. And when you run a wage regression and include all these variables, you can see that high school major, and that includes not only math, but all majors, is contributing quite significantly to the explanation of hourly wage. And perhaps this is kind of a simulation that we did. We took the population of students who studied math at 4 units and simulated what their wages will be. Actually, not only wages, but also field of study in college will be if they studied math at 5 units. And you can see that, especially at the bottom, you see that exact sciences and computer science, the rates of studying these fields actually doubles if they just go higher in math in high school just by one level. And when we simulated the effect on hourly wage, we saw that for females, more than half of the impact of high school math on hourly wage comes through the choice of college major, slightly less so for males. So to summarize, I think this paper is an important contribution into the literature on the value of human capital of different kinds in general, and in particular for the school to work transition. And the question is, if we think about the future labor market, what it actually implies, because futuristics say that future labor market is going to be associated with high rate of job changes. So if you go into an occupation or field of study with a strong linkage, perhaps it limits your opportunities in the future. And this offers some ideas for comparing again European systems and American systems. How will German workers compete in a future labor market where they have to switch jobs quite often, but they're still stuck with their strong linkage to their educational qualification. So yeah, so I think I'll stop here.
So just one comment. Strong linkage doesn't necessarily mean specific skills, and that's the obvious interpretation. But it's possible that they actually have general skills, but they track into the workforce in specific occupations. And I don't know the answer. I'm just saying one doesn't necessarily.
Yeah.
This may be more obvious to those of you who deal with these subjects on an everyday basis, but can it be that part of the benefits of a strong linkage between school and work is a kind of a guild effect and not related specifically to skills?
Yeah, it could be. Well, remember my two conjectures. One conjecture was productivity skill conjecture, and the other was an institutional conjecture, or collective stronger solidarity. And so yes, it could be a guild.
Yeah, guild more in being able to push people who are not in the guild out, more in not being able to negotiate.
No, I mean, I think that's possible. And that triggers a couple of other sort of related comments. One comment was the comment about the endogeneity, because this is partly an endogeneity issue. I mean, so we have data for France and Germany back to 1970. And it should be possible to learn some things about how these systems evolve. And I mean, the German system actually doesn't evolve as far as we can see. The French system, only in East Germany comes in, which is even more strongly linked, and so that's a big change. But the other thing I was going to say, which was the comment that was made about self-selection and non-random selection and things. So there was another part of this paper that we cut out that where we used the PIAF data. Because the PIAF data has some fields of study and it has scores, test scores and things like this. So the issue was, what if we controlled for that? The problem is PIAF is too small. So we like the point estimates in the sense that the point estimate for linkage didn't go down, it actually went up when you controlled for stuff. The problem is the standard errors are so large that, I mean, I wasn't going to try to make a case